These are the notes for graphing two-variable inequalities. This goes with section 5.2 in the book. First, we need to have two definitions. The first is constraint. A constraint is a limitation or restriction, and in math, we usually write constraints as inequalities. It's one way to signify a constraint. The second definition is solution set. A solution set is the set of all possible values that make an equation or inequality true. You've seen solution sets where there is one solution that works. You've seen solution sets where there are many. So keep in mind that solution and solution set doesn't necessarily mean one value, like x equals 10. So the example we're going to use is graph y is less than x plus 2. Then pick a point that is in the solution set. So the first thing I'm going to do is I'm going to draw in my axes, labeling my axes, and then scaling them. And I'm scaling it by every box being 1, but I can signify that by simply going over 2 and signifying that that's 2. So we see here that the y-intercept is 2. So on the y-axis, I put a point of 2. We then see that my slope is the number in front of the x, and if there is no number, that means that the number is 1. So I'll go over 1, up 1, over 1, up 1, over 1. Or I go down 1 to the left 1. Down 1 to the left 1, down 1 to the left 1. Remember, a positive slope goes up from left to right. It also is positive, positive makes a positive, positive, positive makes a positive, or negative, negative makes a positive. Now, at this point, because I'm graphing an inequality, I have to take into consideration two things, just like when you graphed inequalities on number lines. One, I have to consider whether or not this is an open circle or a closed circle. In this case, because we don't have an or equal to piece, this means that I have to somehow denote that this is an open circle. When you were doing one variable inequalities, so just a one number line, you did that by drawing an open circle. In this case, I don't have a way to draw an open circle in that same way. So what we do is we make our line dashed. This signifies that my answers are not on the line. They're right up to the line, but not on the line. Now, the second thing you had to do when you graphed one variable inequalities was to decide where to shade. So in this case, we need to decide whether or not we're shading above the line or below the line. And the easiest way to do this is to pick a point and test it. My favorite point to pick whenever I can is the point 0, 0. So we're going to say test 0, 0. So I have my inequality, y is less than x plus 2. I plug 0 in for y, plug 0 in for x. And I ask myself, is this true? Is 0 less than 2? And it is true, which means 0, 0 is part of the solution set. It is a point that makes the equation true. So then I shade the side of the equation, the side of the line, that includes the point 0, 0. So now, if I then have to pick a point that is in the solution set, I've already done that. I could say that 0, 0 is a point in the solution set. I could also pick any point that's in this shaded region. So over 2 up 1, over 3 up 2, over negative 1 down 2. Any of those points would satisfy the equation. Now let's say I had done all of this work and I had gotten I'd gotten a false statement. Well, that means that I don't want to include 0, 0, which means I would shade on the side that didn't have 0, 0. There's also one other thing to keep in mind, which is that I tested the point 0, 0 because it was on one side of the line. If the line went through 0, 0, it wouldn't be on one side. It would be part of the line. And so I'd have to pick a different point.